Hey, what's up guys? This is Fatal Cubes here, and in this video we are actually going to be working on the game logic. So this is, I think, part 7 of the 2048 tutorial series in Java, and let's get right into this because we have a lot to do this video, and it is pretty complicated, so you guys are going to have to make sure you're focusing. If you're not focusing, then just leave the video right now. Anyways, let's start off by now we're actually going to get to moving the tiles. So if it's left, we want to move the tiles with the direction.left. We will make this function in just a moment, but go ahead and copy that down for all these. Up and down. This is going to be right, this is going to be up, and this is going to be down. So if you haven't guessed it, you need to go ahead and make a function called private void move tiles, and this is going to take in a direction, and we're just going to go ahead and call this direction dir. That's right, direction dir. This is going to handle moving the tiles. So if we're moving it left, we need to update it one way, right, down and up, whatever, etc. So we need, first of all, a boolean can move, because we need to keep track of if when they hit the left key, were they able to move, and if they weren't able to move, then it's not going to do anything. And yeah, same thing with right. Oh well, if they can't move, then you don't spawn in a tile, basically. So you only want to spawn in a tile if they could move. We need a horizontal direction, set that to 0, and a vertical direction. You'll see what these are about in just a moment. Alright, so we gotta create a bunch of for loops here. And I was thinking of a better way to do this, but no solutions came to me. This is as simple as I could get it. So if it's left, then the horizontal direction equals -1, and we're not going to change the vertical direction because we're moving to the left. So you think about it on like an axis plane, you're moving negatively on the x and not at all on the y. So then we're going to go through each one. Row equals 0, rows less than rows. So we're going to iterate through the rows and the columns. Like so. And we're going to say, well, if we haven't moved yet, if so far we haven't been proven to be able to move, then can move is going to be equal to this function we're going to create called move row column horizontal direction, vertical direction, and direction. Else, we're just going to move it. Alright, so before I lose you guys, I'll try to explain what's going on. So it's going to go through each one, and it's basically going to move each tile individually. We're going to make this move function, and what it's going to do is it's going to predict the position it's going to be in. If it can combine or if it can move, then this function will return true. Once it's proven that you have been able to move at least one tile, then can move is going to be equal to true, and it can't be set to false. So if we just set can move equal to move, then this variable will be will be either true or false based on the last tile updating. So I hope that makes sense. We have to do it this way. Otherwise, this will be false if the last tile can't move, and it'll be true if the last tile could move. Whereas we just want to say, well, if any tile can move, it's true, and if all the tiles can't move, it's false. Alright, now we're going to have to copy this 4 times. So, for all the directions. Again, it seems a bit messy copying and pasting like this, but you'll see why you can't just condense this anymore in just a moment. So we have all of our directions. If we go to the right, we want to set the horizontal direction to +1 and not change the vertical direction. And we got to change this. Yeah, that's right. This is why you can't condense it. Call equal calls minus 1. Call is greater than or equal to 0. Call minus minus. Basically, if you're moving to the right, then you want to start. Wait a second. Yes, so if you're moving to the right, you want to update all the tiles from the right to the left. And the reason being is that if you were to update them from left to right, and let's say, I'm trying to think of a hypothetical situation. Alright, if you had 2, 2, 4, 8, and you update, you say this 8, can it move anywhere? No. Okay, next one. 4, can it move? No. 2, can it move? No. 2, this 2 can combine. So this would essentially become blank spot 4, 4, 8, which is what we wanted. If we were to update from the left, watch what happens. This 2 would say, I can combine. Now I'm a 4. Now I can combine. Now I'm an 8. 16. So it essentially would become this. Where in one move it would become that. So what we want to do is we want to update from the right, and this simplifies things and it makes the game logic makes more sense to do it this way. So again, everything's the same except for the horizontal direction, and yeah. So this one we're just changing the vertical direction equal to -1, and we want to keep this the same. We want to update from the row. Remember, the row is what we'd be changing, and we want to start from the top. This is going to be vertical direction, and it's going to be set to +1 because we're going down. And row is going to set to rows -1. Row is greater than or equal to 0. And row minus. So make sure you have that right. I can definitely see someone rushing through this and not being careful and then getting this issue. But yeah, that's it for this. Yeah, that's mostly it for this method. There's a few more things we can do. At the very end of this, you want to say, well, go through all of them. Alright, we're going to do another double for loop because we need to update something about all the tiles. First of all, let's get the current tile. And this is going to be a board, row, column. If the tile is null there, that's okay. We'll just continue the loop. We'll go on to the next one. Otherwise, we're now going to set can combine to true. Set can combine. Yes, so in tile we need to add something real quick. We need to do a bunch of things in the tile class. I forgot about that. First thing, I know this is kind of going all over the place. Just keep up as best you can. We're going to create a class called point. And if you recall, if you know about Java, you know there's a class called point that takes in an XY position. Because we're working with row and columns, rows translate to Y's and column translates to X. It'd be a bit confusing if we use the normal point class. So we're going to create our own point, and all it's going to have is 2 public integers, row and column. This is all you need. This is a very small class. It just stores a position that goes by row and column. In tile, you need to create one of these points by doing private point slide to. Now, when it goes to import, it should make sure it is your com.fatalcubes.game.point instead of the java.auth.geom or whatever. I can't remember what it's called. So yeah, what is this? This means that when you eventually when you slide, you need to say, well, where does the tile end up? And how can we make that sliding motion? So this will be a point that stores the row and column where the tile needs to go to. I'm just going to create, you know what, all we need to create here is a private boolean can combine. This keeps track of if the thing has already combined or not. Because again, you wouldn't want that 2248 thing. You only want each one to combine once. So create a getter and setter at the very bottom. You can uncheck this if you want. That should go ahead and put this is can combine, which I'm just going to change to can combine. And set can combine, yeah, okay. Getters and setters, basic stuff. And the same thing with the slide too. Let's just create a getter and setter for that. Okay. And there we go. Anyways, now we can set the can combine to true. Because remember, no matter what happened in all the updating, now it's back to, we need to reset it, set its default. And if it could move, then we're going to spawn a new random one. We created this method in the last video. And we're not going to create this method yet, but we normally check dead. Check if you're dead. Alright. And the last thing we're going to do is, these should all be else if statements. Else if. No point in checking all of them when you can really only go in one direction. And that is a band name. Just in case something happens and they put it in the wrong direction, you can catch it by doing this and just saying that's not a valid direction. Okay, so far we created this function called move tiles that takes in a direction. Depending on the direction, it'll set the horizontal direction either negative or positive, basically. And it's going to set the vertical direction. These would be technically setting it to 0, and these would be setting the horizontal direction to 0. And then also, depending on which way you're going, it's either going to update from left to right, right to left, up to down, or down to up. And we're just going to move that individual tile. So let's go ahead and make that function. And I told you guys this is going to be a lot of stuff in this video. Though this will be all the logic after this video, you won't be able to run it quite yet. We need to do a bit more. But yeah, the next video we should get to running it with no animations. So now let's create that function that takes in a row, a column, a horizontal direction, and a vertical direction. And it's going to take in one of our directions. Direction dir. First of all, create that can move. Because remember, it's got to return a boolean. It's basically at the end going to return can move. Anyways, let's create some room. First thing we're going to do is get the current tile from wherever we're getting it. Tile current equals board at row and column. Once we have the current tile, we first of all want to say, well, if current's null, again, we can't do anything there. We're just going to return false. You can't move this tile, and there's nothing else to do. So if this gets caught, it's going to return, it's going to come out, and it's going to be false. Well, if it's not, if it is not null, then we're going to create this boolean called move, and you'll see why in a moment. Int new column is going to be equal to the current column, and new row is going to be equal to the row. Now we're going to create a while loop that says while the tile is able to move, basically while the tile is able to either combine or just slide to an empty tile and hasn't reached one of the walls, then we're going to keep checking things. So while move, we're going to get the new column is going to plus equal the horizontal direction. So again, if we're setting the horizontal, if you're going left, the horizontal direction is going to be -1. So the new column would be 1 less than the old one. And the new row, if we're going left, would actually plus equal 0. So it wouldn't make much of a difference. But you do need this line of code here if you want to move up and down. Plus equal vertical direction. Spelled that wrong there. Now we need to check if it's out of bounds. So check out of bounds with the direction, the row, and the column. And if that returns true, we're just going to break out of the loop. It can't move anymore. So let's create this method. Alright. Okay, so check out of bounds. We're going to go through all the directions. If the direction is direction.left, we're going to return if the column is less than 0. So if that's true, we're going to return yes, it's out of bounds. We're going to int row, int column. Else if the direction is right, we're going to return the column is greater than columns -1. Else if the direction is up, we're going to return the row is less than 0. And similarly, the exact same thing for down. Direction equals direction dot down. Return row is greater than rows -1. So this is going to take in a direction. It's going to check to see which way you're trying to go. And if you're going left, then you have to check on the left side if it's out of bounds. Right, up, down, similar things. And at the very end, you need to just return false. So if for some reason none of the directions are caught, we'll just return false. Though that shouldn't really ever occur. Anyways, going back to this function. Going back to this move function. If we haven't broken out of the loop yet, we have to check a couple things. We have to check if the board at new row and new column equals null. If it does, you obviously can move there. So board at new row and new column equals the current. So it equals whatever the current tile is. Board at the new row minus the vertical direction. And the new column minus the horizontal direction equals null. So it's going to say, well, the new place I'm going to is going to equal to whatever the current tile is, and the old place is going to be set to null. And the board at the new row, new column dot set the slide to new point at new row, new column. That's basically going to say take that tile and set the new place it's going to end up at. So it's going to set the point to where it needs to slide to the new row and new column. Now this is all for checking if the tile is null or there's basically an empty space on the board. We also need to check if you can combine. So if the new row and the new column dot get value, what am I doing? Equals the current value. Well, the current tile's value. And the board at that new row and column that you want to combine with can combine. So if it's already combined once, you can't combine multiple times in each move. So we're going to immediately say, well, the new row and new column dot set can combine to to false. You can no longer combine anymore, but we will at the new row and new column set the value. And why isn't that? We need to create that for a moment. Under get value, just create a setter, public void set value, int value, this dot value equals value. We're going to set the value equal to whatever the current value is. So again, board at new row, new column dot get value times 2. Basically, we're going to double it. Can move is going to be equal to true. Again, we're going to set the tile before it. So at the new row with minus the vertical direction and the new column minus the horizontal direction equal to null. We're then going to set the slide to new row and new column. We're going to set the slide to a new point at the new row and new column. That's where it's going to end up being. And we're going to set the combine animation new row. Set the combine animation to true. Alright, we'll do that when we do the animations, but I just want to leave a note to myself. And you want to add to score. Again, we're not going to do that right now. I'm just keeping these notes in because we will do this eventually, just not right. It's not important right now. Else, move equals false. So it's going to go through, it's going to add, predict the next position. If it's out of bounds, we obviously break, that's it. End of the function. Return whatever the can move value was set to when you broke. Otherwise, check if the value is null. If it is null, move there, and then continue looping. Else if it can combine it, but then say you can't combine anymore. And then if none of that's true, then moving is just going to be set to false. Alright. Now technically this really should not get hit because this will get hit first. But having this in is good. Very good. And I think that will be it for this video. Let me see if we have anything else planned. In the next video, we will actually get to drawing the tiles, and we will get to drawing the tiles and actually sliding them across the board and stuff. No animations, but you will get to play your game, basically. So yeah, I think that's it. Next video, we will check for being dead. We will check moving, and yeah, I guess I'll see you guys there. Bye.